every single grade, and that's the story of the evolution of Wade.
Page 2. All right, we got another table of values, just like they do on the AP test. Okay, integrate from 0 to 12 this function right here. All right, the integration of 2 is normally 2x, although with a dt, it's 2t, but it's like 2x, you know. The integration of the derivative by the fundamental theorem of calculus is the original function, evaluated from 0 to 12. Seems like there's a 12 in the table. That's probably intentional. It is. So then, when you plug in top minus bottom, the top number 12 would get plugged in, and you would get 2 times 12 is 24, minus f of 12, minus, plug in the bottom, 0 minus f of 0. Okay? All right. F of 12, it's in the table, it's 3. F of 0, it's in the table, it's 0, but not always. Don't always assume that f of 0 is 0. And then that group's going to cancel out. 24 minus 3, 21. Done. All right, let's check out 8. Find the rate at time equals 13, but actually you can't find it because there's not enough information. It says approximate it, estimate it. We can only guess. All right, rate means derivative. There's no function. It's just a bunch of numbers in a table. There's nothing to take the derivative of, which we normally would do. So how do I estimate the rate? Well, 13 does fall between 12 and 14, doesn't it? Somewhere right in here is where 13 would be. So the idea is to take the surrounding coordinates around 13 and do the slope of the secant line, which is very roughly the same as the slope of the tangent line, approximately. You know, it's that old thing where we used to get really close together, like 1/1000th apart. And if you do the secant line between two little points, you pretty much get the tangent line at that point over there, roughly. Okay, this is going to be a terrible approximation, as I normally say in class. But you're going to do y2 minus y1 over x2 minus x1. And that's going to give you 1 over 2. Okay, so very roughly, this was the record snowfall in one day. Only one city in America has ever gotten 6 feet of snow in one day in 24 hours. This happened, real true story. So the 1/2 represents the rate of something. It's the snowfall, right? 1/2 snowfall in what? Feet per hour, because the x is hours and the y is feet. So that's 1/2 of a foot per hour that it was snowing at that time. That's a lot of snow getting dumped down on the earth, that's for sure. Wow. Okay, number 9, we have an integral to estimate. And it says we're going to use a left-hand Riemann sum. Okay, so in the table, we're going to take the table to estimate this because there's no function to integrate over there. So we're going to estimate this with 1/24 times. Okay, left Riemann sum. All right, in the table, we're going to go from 0 to 10, 10 to 12, 12 to 14, and 14 to 24. All right, now, it's really right at the top there, isn't it? Barely in there. Okay, the first rectangle is a width 10 by left sum. So the left number tells you the height of the curve at that point, the height of the rectangle you're drawing. That's a 10 by 0. 10 to 12 is a 2 by left number, 2 by 2. 12 to 14 is a 2 by left number, 3. 14 to 24 is a 10 by left number, 4. You never use the 6 in a left-hand sum. So let's put that over here. We've got a 10 by 0, which you could just skip. We've got a 2 by 2. We got a 2 by 3, and we got a 10 by 4. All right, as I say in the South. And we're going to add up all these things together right here. Okay. So you're going to get nothing there. 4 plus 6 plus 40. And that's going to make, I guess you could actually technically put equals here because this is exactly this. This is roughly that. So, you know, a little bit of nuance there. If you add all this together, you're going to get 40 plus 10 is 50 over 24, which you could reduce to 25 twelfths. And that's how you do a left-hand Riemann sum. And then number 10, interpret number 9 with units. Okay, so take that number you just found. What is it? They want you to recognize that you just integrated from 0 to something or anything to anything. But this 1/24th, didn't that actually come from 24 minus 0 placed off to the side? So they want you to recognize this as an average value, which we did previously on this sample test. They want you to say, oh, this is an average value problem that I just did. But replace the word value. Value always means y-coordinate in math. What's the y-coordinate? It's cumulative feet of snow that have already piled up on the ground. So instead of saying average value and losing a point, say average cumulative snowfall was 25 halves feet. Okay, we don't ever say 25 halves feet in the real world, right? You would want to convert that into a decimal. In the real world, don't just save time. Just save time on the test and on the AP test and on my test. Just write it like that. That's the average feet of snowfall on the ground. Now you'd want to say one more thing on the interval from 0 to 24. Otherwise, the AP graders play stupid and they're like, well, on what interval? On 0 to the first hour? When was that much snowfall on the ground? So you have to tell them, like, on this interval, you bozos, you put it right there in front of my face. It's clearly 0 to 24, but you still have to put it down. Okay? And that's a great explanation. All right. Number 11. I've erased some of the table to only focus on the most important parts now, 14 to 24, because both of these questions are only asking about 14 to 24. So we've erased the distractions. Look at just this information right here. Okay, let me get over here so you can actually see me in this at the same time. Verify that there had to be 5 feet of snow on the ground between time 14 and time 24 hours. Well, at 14, you got 4 feet. At 24, you got 6 feet. How about by the common sense theorem, right? I mean, I know that you feel like writing that, so do I. Well, yes, sure, there were 5 feet on the ground. There were also 4.1, 4.2, 4.3 on the ground. So you want to recognize that as an intermediate value theorem. Between these two places, there was 5 feet of snow on the ground. So they want to see the word IVT in there, intermediate value theorem. Also, remember that intermediate value theorem only works if the curve is continuous. So you would also want to mention that too. So here's a great way to say this. Because f is continuous, the y coordinate or f reaches every number from 4 to 6 on 14 to 24 by the intermediate value theorem. Okay? There are lots of ways to write it. I know that seems like a lot of words to write on a math test. You have to do this on the AP test. Just get IVT in there, get the interval in there, get continuous in there. And then in your own words, just explain that it reaches everything from 4 to 6 and everything in between. Any way that you want to, there's so many ways to say it, okay? But they want to see that intermediate value theorem. And it's kind of the same thing for number 12. You're telling me that somewhere on this interval, even though we don't even know what equation this is, you're telling me that you know beyond a shadow of a doubt that the snow was falling at 1/5 of a foot per hour exactly at some point? Yes, we do. That is the mean value theorem. Here's what you want to realize. Feet per hour is a derivative. And a derivative is a slope. That 1/5 is no accident. It is not random. It is always the slope from the table. Okay? So somewhere like on the AP test, not on my chapter test, but somewhere on the AP test, you would want to write out the slope is y2 minus y1 over x2 minus x1. So they do want to see that in your work, that you just didn't pull that out of thin air. And then you can realize that that's 2 over 10. And as soon as you see that 2 over 10, you're like, yep, gotcha. You tried to fool me and it didn't work because I know that the rate is 1/5 somewhere. Now explain it. because now remember, every theorem has to be for continuous functions, except the mean value theorem is the pickiest of all of them, because f is differentiable. This theorem does not work just on any old continuous function. It has to be a differentiable function. Because f is differentiable, let's say that the tangent slope equals the secant slope of 1/5. This was the secant slope. The tangent slope is the derivative, but there's nothing to take the derivative of. So this is your secant. So you know it happens somewhere by the mean value theorem. Seems like a lot. I know it does. But remember, well, let's just circle this part. Remember, get the word differentiable, get the MVT, mean value theorem, in there, and then in your own words describe the fact that the slope of the secant was 1/5, so the slope of the tangent has to match it. Okay? Anything like that will work.